Hello everyone, welcome to Dr. Ravi's Academy. In today's virtual class, we will be solving a problem on free vibrations, and that problem is which involves determining the equivalent stiffness, and finally we want to calculate the frequency of the vibration. Let us understand the importance of the frequency of vibration. As a mechanical engineer, we are trying our level best to calculate the frequency of the systems. And as you know that resonance, when the external frequency is matches with the system frequency, unwanted or violent vibrations takes place. The amplitude of vibrations is violently increasing, and the system will collapse. And that is the reason, to avoid the resonance problem, we are always focusing on determining the frequency of the system, so that we can design our system which avoids resonance problem. So keeping in that view, we are involved in finding out the frequency of the systems. Let us look at this two springs. A ball is connected by means of two springs, and observe carefully here. The springs are connected to the mass only. If spring to spring connected is series connection, spring is connected to the mass, and again spring is connected to the mass. Is this particular configuration is similar to this particular configuration, which is parallel. Observe carefully, this is parallel. So as you know how to calculate the spring stiffness. Ke is equals to, it is algebraic sum of k1 and k2. In this case, both are, it is k and k only, 2k, and that k value is given, spring stiffness is given, it is 200 Newton per meter. So 2 into 200 Newton per meter, that is 400 Newton per meter. So this is the equivalent spring stiffness. Let us calculate the omega radian frequency of the system. This is spring stiffness Ke by mass of the system. Here in this, the weight is given. The weight is given, and if you divide it by G, you are going to get Ke is 400 divided by mass is 5 divided by G. 5 divided by G under root. So this you are going to get 28 radians per second. And let us calculate the tau, the time period. Time period is nothing but it is 28, it is 2 pi by, you can calculate the frequency of the system. Frequency of the system, Fn is equals to 1 by 2 pi is Ke by mass, and this you are going to get 4.46 hertz cycles per second. And the time period is tau is the reciprocal of frequency, that is Fn. So this you will be getting it as 0.224 seconds. And he is asking even the maximum velocity. The maximum velocity is equals to, that is maximum amplitude r into omega, and r is, here it is given that it is it is displaced by 2.5 centimeters divided by 100. So that is 0.025 in meters, and omega you have calculated, that is 28, and this gives you, velocity is 0.7 meters per second, the maximum velocity. So in this particular problem, mainly we are very much interested in frequency of the systems, how to calculate the frequency by calculating the spring stiffness of the system. Thank you for watching this video.